Okay, so welcome back to another video. So in today's video we have a partial sum of a trig function. So our partial sum starting with our index k is equal to 1 to 2020 of 1 divided by sine of k multiplied by sine of k plus 1. And so keep in mind the notation over here is not the exponent 0, this is actually the degrees. So in case you haven't guessed, we're actually going to be working with degrees instead of radians, so this is going to be an interesting twist. So anyways, like I said, we're going to be working in degrees. Nothing special here, but just like the notation is going to be different otherwise. But anyways, let's just jump straight in. I'm going to define this our given as a variable, call this u. So it's u is equal to our partial sum. So k is equal to 1, and 1 divided by sine of k degrees, and then multiply by sine of k plus 1 degrees. Okay, and so now what I'll do is I'll actually multiply a sine of 1 degrees by both sides. So then we have sine u times sine of 1 degrees, and that's equal to, okay, so let's see, sine of 1 degrees. And now what I'll do is I'll actually expand this whole summation out. So let's see, we get k is equal to 1. That means over here this should be sine of 1 degrees, and then multiply with sine of k plus 1. So that means this will be sine of 2 degrees. And then I'll add the next one, so it increments by 1 from each term. So let's see, this will be 2 degrees, and then sine of 3 degrees. And then you'll see the pattern continue, so on and so forth. So then we go up to 2020, so that means this will be 1 divided by sine of 2020 degrees multiplied by sine of 2021 degrees. Let me center this one over here just a bit. Alright, nice. And so when I do this, I can actually just distribute the sine of 1 into here, so I'm just gonna skip that step. Well, I mean, like, clip that footage out so you don't have to see me rewrite this whole thing. I distribute the sine of 1 into our series expansion over here. And so what I'll do is that I'm going to manipulate this equation a bit. So what I'll do is I'm going to rewrite our inputs from all our numerators such that, so let's see. What I want to do next is we want to, eventually what I want to do is I want to use a little trig identity that's very commonly known that you'll use in high school algebra and that stuff, well, pre-calculus specifically, so that way we can use that formula after rewriting our inputs. So what I'll do is rewrite this as, so from our first term, so this will be a, actually this is supposed to be 2 minus 1, so like I just said, first term is going to be a 2 minus 1 degrees, then sine of 1, then sine of 2, and this will make sense using that trig formula eventually. Okay, so over here I'll write sine of 3 minus 2 degrees, and then we have sine of 2, and then sine of 3, and then over here I'll have a sine of 2021 minus 2020 degrees, and then subtract, and then that's being divided by sine of 2020 degrees, and then multiply with sine of 2021 degrees. Okay, so now we're going to be using our little trigonometric formula here. So the identity is that if we have that sine of x minus y, okay, that's actually going to equal the little identity over here, sine of x multiplied by cosine of y, subtract that with, yeah, actually, I'll write like this is okay. Minus cosine of x, and then multiply with sine of y. So we'll just use this identity to rewrite some things from our numerator. When I do this, so far, let's see, this is still equals 2. And then this means our x we'll call this 2, and then our y will be 1, and then basically all our x's are from the left, and then all our y's are from the right of our specific input. Okay, so when we rewrite this, I have, let's see, this is sine of 2 degrees, then multiplied by cosine of 1 degrees, subtract that with, let's see, cosine of 2 degrees, and then multiply with sine of 1 degrees. And I'm just going to cut to the next clip until I completely write out our rewritten numerators using this identity. After rewriting our numerators from our distribute with the expansion, so we have the following over here. And so what I'll do is next is that we notice that some terms will cancel from both the numerator and denominator. So what you'll notice is that, let's see, we notice that sine of 2 from here cancels, so we have a cosine of 1 divided by a sine of 1. If you use the trig identity, we get that this is also the same as cotangent of 1 degrees. But then from over here, we see that we have a sine of 1 cancels, and then we have a cosine of 2 degrees divided by sine of 2 degrees. Use that identity, the same thing as follows. It's supposed to be cotangent of 2 degrees. And then we can do the same thing, apply the same method for the rest, so that the following we have, let's see, cotangent 2 degrees, then minus cotangent of 3 degrees. Okay, so on and so forth, we keep going. And then over here we have cotangent of 20 degrees, subtract that with cotangent of 20 degrees. And you'll start to notice that this series is actually telescoping, because you'll notice that the negative, the minus cotangent 2 theta and the plus 2 tangent k, that cancels. Same thing with the cotangent 3 cancels. But the other one, 4, 5, you go up all the way so forth, and then eventually you'll reach that. It'll also cancel with the cotangent of 20 degrees. So this means the only terms left with is that we have that this is simply just equal to cotangent of 1 degrees subtract with cotangent of 21 degrees. And let me just write that this is telescoping, just to justify that. So this is telescoping. Let me also reiterate what we have so far. So we have that u multiplied with sine of 1 degrees is equal to cotangent of 1 degrees subtract with cotangent of 21 degrees. Okay, now what I'll do from here is that now we're actually going to use another following trig identity, and that is written as the following. So cotangent of x minus y is actually just equal to sine of y minus x, and then that is being divided by sine of x multiplied by sine of y. Okay, and so we'll use this identity over here to rewrite our cotangent 1 subtract with cotangent of 2021. So this means we have, let's see, sine of 20 degrees minus 1. Okay, and then we subtract, and then that's being divided by let's see, so this will be sine of 1 degrees multiplied with sine of 20 degrees, and then just perform the following subtraction from our input from the top. So far we have that this is sine of 20 degrees, and then the denominator still preserved, so nothing has changed from there just yet. And so now the next step I want to do is I want to compute both these degrees. So how do we do this? You might be thinking that this might be a little this might be too complex to just use like such a huge number in degrees, as it's a big number we're dealing with, especially in terms of degrees. So what I'll do is I'm actually going to think of this with the unit circle. If you think of a unit circle, it goes on a full rotation 360 degrees. So we're going to use that to our advantage to rewrite the input of our inside. So let's think about this. Okay, so I'm going to go from over here. So notice that 2020, if we think about this, we know that it actually performs a full 360 rotation 5 times. Because, you know, 5 times 360 is so let's see, that's 5 times 60 is 350, so that will be 1800 degrees. But then we can also think of it as plus add another 180 degrees, so it performs half that rotation. So this will be, so far that means so far with all the addition we get that it's 1980 degrees, and then add a 40. So with this, I'll just apply to the same thing from below, well, sine of 1 still stays the same, but however, sine of 2021 will just use that same we'll use that same justification from before. So 5 times 360, add another 80, and then plus 41 degrees around for this time. Okay, so now let's think of it in this way. So I'm gonna move this to over here. Okay, so let's first calculate the numerator here. So far we have that sine of 5 times 360 plus 180 plus 40. We can just compute the 3 from those 3 terms here and leave the 40 out on the side. So what we'll get is that this is just sine of 1980 plus 40 degrees. And so what that entails is that what I can do is we can actually use our little trig rule over here, but this time this will be addition. But basically, this is just the same formula from here, but except this will be a addition sign over here. So when I use this rule, so we get that this is sine of 1980, okay, and then we multiply this with cosine of 40, then plus cosine of 1980, and then multiply with sine of 40. Okay, you guys can see that, right? Cool. All right. Now I want to notice that 1980 is equal to what we said from over here was 5 times 360 plus 180. So that means it performs a full 365 times, then add 180. If you think of the number 180 degrees, it's actually equal to pi over 2, or I mean pi. So in actuality, we're actually evaluating sine of pi over here, which, if you know your unit circles well, then that's actually just equivalent to just 0. And then over here with cosine of 1980, that's cosine of pi, and that's actually just equal to just -1. Okay, and so therefore the conclusion is that this is just simply just equal to negative sine of 40 degrees. All right. And so we can actually apply the same argument. So let's actually just calculate the denominator from here, specifically the sine of 2021. So basically we do the same thing. So 5 times 360 plus 180, then add a 40. What really I can do is just calculate from these 3 terms and leave the 41, actually. It's supposed to be 41 over here. This is just, let's see, sine of 1980 plus 41 degrees. And then we just use the rule. So let's see, sine of 1980, then multiply with cosine of 41, and then plus cosine of 1980, multiply with sine of 41 degrees. And so we use the same thing, just the same justification from before. It's just basically the same math, we just added 1 degree to here, but I just want you to understand like what we're doing, what's going on over here. So sine of 1980, that's going to be 0, and then over here this is going to be a -1. So therefore we have that this is just negative sine of 41 degrees. And so with that, we can actually replace our inputs back into here. So now going from here, that means this is going to be, here, I'll draw it this way. So therefore, sine of 5 times 360 plus 180 plus 40, that's just going to equal negative sine of 40 degrees. And then we divide by, so far we have sine of 1 degrees, and then multiply with sine of 5 times 360 plus 80 plus 41, which that's just negative sine of 41. So let's see, negative sine of 1 degrees, and then sine of 41 degrees. Okay, then the negatives cancel. Okay, so far we have that sine of 40 degrees, and then equals sine of 1 degrees, and multiply by sine of 41 degrees. That's established that that's just equal to u times sine of 1 degrees, but we divide sine of 1 degrees to both sides, so we get that u is equal to sine of 40 degrees, and then divided by sine square of 1 degrees multiplied by sine of 41 degrees. Okay, and now to finish this up, let's actually use some trig laws to clean some stuff up. So 1 over sine square of 1 theta is basically just cosecant square of 1 theta, and then sine of 41, 1 over sine over 41 is just cosecant of 41 degrees, and then multiplied by sine of 40 degrees. And there we have it. So therefore the conclusion is that we said that u is equal to our given, which is the partial sum from 1 to 2020 of 1 divided by sine of k degrees multiplied by sine of k plus 1 degrees is simply just equal to cosecant square of 1 degrees multiplied with cosecant of 41 degrees multiplied by sine of 40 degrees. All right, now that's pretty cool if you ask me.